Hi all, welcome to educators.com. I'm Harish, software engineer. In this session, we will be learning about the different design patterns like module, prototype, observer and singleton. So by end of this session, you should be able to understand like where we will be using these design patterns. Okay. So before we dig into these design patterns, let's know about what actual design patterns are. Design patterns are solutions to general problems that software developers face during software development. This means that these patterns are like solutions to the general problems, like uh, the frequent problems or the similar problems or the common problems, whatever it might be, which are faced by the software developers. They can use these patterns as a solutions to the problems. Okay, so these design patterns are classified into three categories. Mainly, first thing is creational, structural, and behavioral. Creational patterns are related to the object creation mechanisms. So it mainly involves in the object creation itself. Whereas the structural patterns are used to simplify the structure by identifying the relationships. Okay, the behavioral patterns are used to provide better interaction between the objects and how to provide loose coupling and flexibility to extend easily. Okay, so these are the three categories in which the design patterns are mainly divided into. Okay, so if you are not satisfied with any existing design patterns, you can create your own design pattern. It's not like you should use only the existing design patterns itself. It's up to you. You can create your own design pattern. Okay, so but currently existing design patterns mostly cover all the general problems. So I think most if you use these design patterns properly, you no need to create any design patterns again. Okay, so let's start with module design pattern. So module design patterns are used to maintain encapsulation and reveal certain variables and methods. Okay, as in some of the programming languages like C Sharp, Java, or any object-oriented programming language, we used to have a class where everything is encapsulated. That means we consider a private scope as well as a public scope. In the same way, we can create this private scope and public scope in JavaScript using the module design pattern. Okay, as in JavaScript we don't have a class kind of thing, we can go with this pattern. Okay, like here in this example, you can check I created a self-execution function. So here you can check I declared a function keyword and then parentheses in which I declared one variable called private variable with value as 10, and then a private method which will increment that private variable value. Okay, and then a public method which will internally call the private method, and a return count method which will return the private variable value. Okay, and in the last I'm returning an object literal which contains two properties, increment count and get count. Increment count contains the value of public method and the get count contains the value of return count. So in this self execution function we have declared one private variable and one private method. Okay, so here these functions will have the reference to these variables. Why? Because when you declare or when you define a function, it will create the scope itself. Like as you have created the function within this function like public method or the written code within this scope, it will have the access to what these variables. Okay, so that's the reason when you return the reference of these functions also, those functions will have the access to these private variables. Okay, so if you don't want to expose some of the properties or methods which will work on that properties, you can use this self-execution method that returns an object literally. Okay, so here on execution of this function, we are getting the reference of the object. So exposer will have the reference to the object which has two properties called increment count and get count. Okay, so when I call the exposer dot increment count, it will call internally the public method, which will internally call the private method that will increment the private variable value. Okay, so when I try to print the exposer dot get count and the private variable value using the get count method, it will give the value as 11. Okay, so this is how we can maintain the private scope and the public scope within the JavaScript. Okay, so now coming to prototype design pattern. Here the prototype design pattern is used to specify the kind of objects to create using a prototype instance and create new objects by copying this prototype. This means that if you want to create an object or exist based on the existing object values, property values, you can follow this prototype design pattern. Like let's say when we create an object, we want to have some default values to that object properties. So to have that default properties, we can have this prototype design pattern itself. Okay, so not only in that case, we can also use in other cases also. Okay, so here in this example you can check that I have declared a customer prototype and the customer constructors. Okay, so let's first check with the customer constructor function. Here it accepts three parameters: first name, last name and status. So it creates three properties called first name, last name and status, and then a method called say, which will print the log message to the browser window. Okay, whereas customer prototype will have the reference to the prototype value, I mean the proto property, which will have the reference to the proto value, and then a clone function which will internally create the customer object and assign the values of the proto property. Okay, so here when I create the new customer object, when I create the customer object using the new keyword, and then I'm passing the created customer object reference to the customer prototype. So when I call this new of customer prototype, it will return the created object. So on the created object, I'm just calling the clone method. So when I call the clone method, it actually returns a new customer object containing the values of the first created customer object. Okay, so this is how we can use a prototype design pattern in JavaScript. Okay, this is all about the prototype design pattern. Now let's look into the observer design pattern. It defines a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and updated automatically. What does this mean? This means that whenever there is a change within an object or anything, it will notify all the handlers which have subscribed to that event. Let's say as in JavaScript we have an event where whatever be the event handlers which have subscribed to that event will be notified when that event is dispatched. So similarly, This observed design pattern is used to notify the dependencies when there is a change in the state. Okay, so here in this example you can check I declared a update notifier constructor which will have the property called handlers with a values empty array. And in the prototype of this constructor, I declared three functions: subscribe, unsubscribe, and fire. Subscribe will add the handlers, okay, whereas unsubscribe will remove the handler, and the fire will call all the handlers. Okay, that means like when there is an event, it will call all the handlers which are registered to this event. So you can check that in the run method. First I declared an update notify handler function which will log the message. Okay, and then I created an object of this update notifier constructor, and then I call the subscribe method which will add this handler update notifier handler to the handlers array. When I fired the event 1 using the fire method, it will call this update notifier handler method. When I call the unsubscribe method of this update notify handler, it will remove this method from the array. And then when I call this fire event 2, it will not notify any of the handlers as there are no handlers registered for this event. When I re-subscribe for this event and when I fire the event 3, the update notify handler will be called. So this is how we can maintain the dependencies notification and then notifying them about the changes state. Okay, now coming to the singleton design pattern. A singleton only allows for a single instantiation. The singleton restricts client from creating multiple objects. So let's say if you want to create only single object and you don't want to have multiple objects of same structure or anything, and you want to go only with the single object. So to have that single object thing, you can use a singleton design pattern concept in your page. Why we need to have this singleton design pattern? When you have some global functions or which are registered at the global level, you can and you don't want to create combine all these functions into a single object, and you want to create only that object only once, then you can go with the singleton design pattern. Okay, so here in this example you can check that I declared a function which contains a local variable called instance and a create instance method, and then return statement which will return a function saying like if the instance variable is not defined, I'm calling the create instance method. So whatever be the value returned by create instance will be assigned to the instance variable, and then I'm returning that instance variable from the get instance method. So the main thing here is after this execution I will have only reference to get instance method. So when I call singleton dot get instance method, it will first create the object. So when I call again the same method, it will return me the created instance. That means it will not recreate the instance again. It will return the reference of that instance. That's all from this session. Thank you.